Okay, sometimes things just don't fit any of our patterns. So there's nothing to break up here. There's no trig functions involved, so I can't hope to use some trig function trick. I don't have the degree of the top being smaller than bottom, so I can't bring a long division thing in. There really isn't a whole lot that we can do. Now you might think, oh, what if I uh, tried to rationalize the denominator? That's a reasonable thought. Unfortunately, that would actually just give you 1 plus square root of x over 1 minus x, which is actually in worse shape. Which is actually in worse shape than the original thing. Uh, so unfortunately, no, that doesn't help either. Uh, Unfortunately, that doesn't help either. Uh, so this is what I kind of refer to as let's just do brute force and hope. Since there's nothing else to do, let's let u be the denominator. Right. Now we don't have the derivative of that denominator hanging out up top. That's not there. That's a problem for us that we're going to have to address. But for lack of anything else, let's try letting u be the denominator and see if we can somehow force our way through this problem. So we begin by letting u be 1 minus square root of x, or x to the 1/2. Then if we differentiate it, du would be the derivative of that, negative 1/2 x to the negative 1/2 dx. Okay. Now, unfortunately, I don't have any of that stuff. So here's what I'm going to do. Here's what I'm going to do. So first of all, I have my u accounted for. Okay, I do have that. Okay, but I don't have the variable piece I need to let the dx part carry through. Right. So what I'm going to do instead here, because I have no other hope, is I'm actually going to take this thing here now, and I'm actually going to solve this for dx, right, and hope that I can do something to that. Okay, hope that I can do something to that, and maybe I can do something. We're just hoping I can do something. It's kind of really what we don't really have anything else to try, so we're just kind of hoping here. So what I'm going to do is solve for dx and see if somehow when I have that solve for dx, I can maybe use this relationship to transform my dx into something involving du. That's kind of my hope. So I start solving for this equation for dx. So first of all, let me rewrite the way that looks for a moment. Du equals negative 1 over 2, and the x to the negative 1/2 needs to go to the bottom. That'll become square root of x dx. So solving for dx, I bring all that stuff over and get negative 2 square root of x du equals dx. Okay. So that lets me at least bring in this radical x. Okay. But I want my dx to actually involve just u's. So now if I go back to my equation here, u is equal to 1 minus 1/2 x to the minus 1/2. I can rewrite that and notice that u is equal to 1 minus the square root of x. So I can actually solve that for square root of x. So then square root of x would be 1 minus u. Right? And that's the key idea here now. Is now I can transform my dx so that it involves just u. So doing that, we would have minus 2 times 1 minus u du will actually replace dx. And that's kind of the key idea there. Because now that thing is what I'm looking for here for my dx. I already have this to become 1 over u. And now this becomes x. So what I've managed to do is I've kind of struggled around. I didn't have what I needed to carry the substitution through. So what I did is I solved for dx. Okay, I got dx, but right now it's in terms of x and du. So I went back to my relationship and tried to solve for the stuff I'm missing, which in this case is square root of x. So that way I can get square root of x in terms of u. Now I've managed to go 1 over u, and I now have what dx will become, which is this. And I can see if now I can work out that integral, or maybe I can't. So back to the integral now, I would have 1 over u times minus 2, 1 minus u du. So I've changed my variable. But boy, I had to really work for it here. To do it. And so simplifying, we see that this would be the integral of negative 2 plus 2u all over u du. And then we can break that up into 2 pieces. Minus 2 over u plus 2 du. And then we can integrate those 2 pieces. Remember, 1 over u is natural log. So this will be negative 2 natural log, absolute value of u, plus 2u plus a constant. And then we substitute back in for what u is. Negative 2 ln absolute value 1 minus the square root of x plus 2 times 1 minus the square root of x plus a constant. Now that answer is fine as it is. If you multiplied that out, that would be 2 minus the square root of x, or 2 minus 2 square roots of x. So you may see a textbook give you the answer in this kind of uglier format. Minus 2 ln absolute value 1 minus the square root of x minus 2 square roots of x plus a constant, where they leave that other 2 out. Textbook people like to do things like that because because it's sneaky, right? That 2 is a constant, so when you put it with that c, you get a new constant. So you could see that kind of thing in a textbook example. They may even absorb the minus 2 from the ln there into an exponent and give you ln of 1 over that quantity squared. Yeah, it's a possibility too. They could do something like that. Okay. So, but the key idea here was we have to change our variable completely over to u. But it doesn't go smoothly, right? Because we don't have any extra stuff to be absorbed. So what we do is we solve for dx, but then we try to do the work to get dx so that it's in terms of u. Right? And that's what this solving back was required here to do. So kind of brute force and hope that we get something that works. Hope we're able to piece something together that actually works. Okay, so that was that example there. Definitely one of the harder ones, but it shows at least that idea of trying to change the variable from one to another when things don't go quite so smoothly. Okay, where you can't just absorb it in because we don't have it there. Okay, and so there are still some that we can work out, even when we are lacking that variable stuff that we need.